This is Note-Taking Guide 11.3 for Math 2. Today we're going to talk about conditional probability. If I was going to describe to you what conditional probability is, it would be the probability of event A given that another event has already occurred. So again, it's the probability of event A given that event B has already occurred. And you could write that down right here if you wanted to do that. Example 1 says 2 6-sided dice are rolled. Find the probability of landing on 5 on your second dice. And then the line right here meaning that or knowing that the probability of the first one already occurred. So the probability of 5 on the first dice has already occurred, and we want to know the probability of 5 on the second dice are occurring at the same time. So let's just circle on our chart here the probability of getting a 5 on the first dice. So 5 on the first dice would be right here, where the 5 is in that first dice position. And then out of those first that have 5 in the first position, we want to know the probability of getting a 5 on the second dice. Well, there's only one 5 occurring on the second dice right here, so our probability would be 1 out of the total right here, which would be 6. So my probability is 1/6. On the second one here, it says find the probability of doubles if the sum of the dice is at least 8. So again, this probability has to happen first. So I know that my dice have to add to 8. So these are the ones that add to 8, and then 9, 10, 11, and 12. So just to see these probabilities right here, this would be the number that would be possible out of the first probability that needs to occur. After that, I need to find the ones that are doubled out of that. So out of those, I have 6 and 6, 5 and 5, and 4 and 4. So on that probability right there, I have 3 possible doubles out of 15 total, which would be a probability of 1/5 that those happened. All right, again, we're doing that one first. So we're going to go doubles first, and doubles go down the column right here. So there's 6 possible outcomes for doubles, and I want to know that the sum is at least 8 out of those doubles. So I'm looking for the ones that are at least 8. That would be 12, that would be 10, that would be 8. So I'm 3 out of 6, which would be 1/2 for my total probability. This next example here says 65 students were surveyed about watching sports on TV. 50 students said they like watching football, and 20 students said they like watching soccer. Of those students there were 5 that liked both. So figure out the probabilities below based on that. So what I want to do is I want to make a Venn diagram that kind of describes this. I'm going to call this the football side, this the soccer side, and then of course in the middle where they overlap it would be both. So I know that 50 students said they like watching football, but I also know that 5 of them had to be in the overlap part, which means 45 were in the football, 5 were in the overlap. 20 students liked watching soccer, but again 5 of them were in that overlap part, so I can only have 15 over here on the other side watching only soccer. So now that I have my Venn diagram filled out, it makes it really easy to find my probabilities of what's happening. So my first probability is the probability of liking football. So I'm going to look at that and I'm going to decide how many students like football. Well, the number of students that like football is 50 total out of a total of how many students? Well, if I add all 3 of these numbers together right here, I'm going to have the total number of students. So 45 plus 15 plus 5 adds together to be 65. So 50 out of 65. And then I would just reduce that on my calculator to get the total number there. So 50 over 65 reduces to be 10 over 13. So I'm just going to write that as 10 over 13. This next one says to find the probability that they only like football. Well, how many of them like football would be a total of 50. Oh, I'm sorry, I said that wrong. The number that likes football only would be 45 out of a total of 65. So if we do 45 over 65, that will give me my total probability. So let your calculator reduce that, and that reduces to 9 over 13 for the probability. This is the probability of them liking both. Well, the both would be this overlap section in here. There's 5 of them that like both out of a total of 65. And that we're just going to reduce on our calculators, 5 over 65. That comes out to be 1/13. And then the last problem on this one, the probability that they like soccer after they already like football. So if they like football, they're in this circle over here. If they like soccer, they're 5 out of the total of the 45. And that would reduce to 1 over 9 for that probability. And maybe I just said that one wrong. Let's take a look at that one again, because the ones that like football, they like, okay, I think I did that completely backwards. Let's start on this one and look at it again. I'm sorry about this, you guys. So let's just take a look at this, and first again, they have to like football first. So the number that like football is 50, and then out of that like soccer would be 5, so 5 over 50. So I'm sorry, that reduces to 1 over 10 instead. I did grab that wrong number there, so make sure you double check this one. All right, this next section here asks us to use this two-way frequency table to figure out the probabilities. So again, we're looking at good mood first. So the total number of people that were in a good mood were 100. And we're looking for those who ate breakfast out of that. So that would be 78 out of 100 for that probability. You can reduce that on your calculator, and you get 39 out of 50. You go to your next probability. You have to look at the ones that ate breakfast. So we're down this direction this time, and so we're looking at 90. Oops, change back. And the ones that were good mood out of that were 78 out of 90. Again, you can reduce that on your calculator. And when you do that, you get 13 out of 15. Then we're looking at skipped breakfast. So a total of 60 that have skipped breakfast. And they have to be in a bad mood. So there's 38 that were in a bad mood. We're going to do 38 out of 60 on our calculator and get 19 over 30 for our solution. All right, one more set right here. It looks like this is a 6-sided dice is rolled and 2 coins are flipped. Find the following probabilities. The probability of a 6 being rolled. So we're going to look at this. And we're going to see the probability of a 6 being rolled. Well, right here, there's 4 times that the 6 was rolled out of a total of 24. If we counted the different options here, there's a total of 24. So 4 over 24, which reduces to 1/6. And then the last problem on here, we're looking for heads on both coins. So we would just go through and highlight the ones that had heads on both coins, which are those ones. And then it has to be that a 6 was rolled. So heads on both coins with a 6 rolled would be 1 out of a total of 6 that we highlighted. So 1/6 for our answer. This is conditional probability. Good luck on your homework.